Hey guys, Trevor Sullivan here, and I just wanted to take a few minutes today to show you how to set up an IPv6 network inside of your Amazon Web Services account. Now, Amazon Web Services has supported IPv6 for some time now, at least in a limited capacity. I know that they support it for EC2 instances, so if you're spinning up a virtual machine on EC2, then you can assign it a IPv6 address, and you can set up your security group rules and your routing tables to block or route IPv6 traffic. And something else that they support too actually is in Elastic Container Service. They support the ability to run Fargate containers with an IPv6 address as well. So if I head over to this task that I have running here, I don't remember if yeah, so I do actually have an IPv6 address on this particular container here. It's running a web application called Pydio Cells. It's basically just a kind of a web front end to allow you to access object storage. It's kind of like Nextcloud in a way, but I think it's a little bit more limited. Anyways, yeah, you can see that I have an IPv6 address right here on my Fargate container. So if you want to just spin up a container-based application and have it listen on an IPv6 address, then you can do that in Fargate without having to spin up any infrastructure. You don't have to spin up the virtual machine or anything. You basically just create a task definition and then deploy your task out here. But what I wanted to do is actually just to show you how to set up a VPC from scratch in your AWS account that supports IPv6. And of course, you could automate this stuff using CloudFormation. You could automate it using the imperative APIs as well, using like the PowerShell SDK for Amazon Web Services. I've got other videos that kind of talk about how to use AWS PowerShell to automate various tasks. But yeah, in this video, we're just going to kind of use the AWS Management Console to go ahead and set up the environment so you can see how to set it up from scratch. There's a few steps. It's not too involved, but just figured I'd kind of show you guys what it looks like from the ground up. If you head over to the VPC console here, right now I've just got my default VPC here. Let me just actually rename this to default just so I can easily recognize it. And then I've got a bunch of subnets here. And actually, one of the other things I wanted to mention too is that if we search for AWS new IPv6, there is an announcement back from November 2021, so fairly recently, just in the last several months, where Amazon Web Services is now starting to support IPv6-only subnets and EC2 instances. So if you're looking to create a virtual private cloud and only have IPv6 addresses with no IPv4 addresses on your EC2 virtual machines, then that is actually possible now as of November 2021. So that's pretty cool. I like that because it's kind of a small step forward into supporting IPv6 as the mainstream protocol for the internet. And luckily, my internet service provider, SpaceX Starlink, actually supports IPv6 in a limited capacity. They don't officially support it, but if you have the right router, I've got an Ubiquiti Edge Router X, and if I configure it correctly based on some directions that were published out there on Reddit, you can actually set up IPv6. Now, they don't officially support it, so if I were to contact them and say, hey, am I having some kind of problem with it, they won't really help me out, but I do have an IPv6 prefix delegation enabled on my router, and so I should be able to ping, IPv6.google.com, and sure enough, I'm able to hit that. So I can actually access, Fargate applications or EC2 instances using IPv6 directly. And, someday I'd like it if, pretty much every service out there supported IPv6 so that I could actually get rid of my IPv4 stack. Obviously, we're probably a couple of decades at least away from that, but the more that we get people kind of thinking in that direction, I think the better off we are. So this is kind of a new feature that's available. But what we're going to do is actually just set up one from scratch here. So I've got 5 subnets right now, and just kind of pay attention to the VPC column here because that's the identifier that the subnet, which VPC the subnet belongs to. So as we're going through and creating VPCs and subnets here, just make sure that you're paying attention to the right VPC ID that we have when we create this. So I'm going to hit create VPC here. And remember, a VPC is basically just a big CIDR block of addresses, and in order to actually deploy anything, you have to subnet it. So a VPC is a regional resource, so you can assign a VPC to like US West 2 Oregon or US West 1 Northern California, and so on and so forth. And so right now I'm actually in the US West 2 Oregon region, but basically a VPC is kind of a region level resource instead of being an AZ or availability zone specific resource. When you actually create a subnet within a VPC, that's where you get the breakdown into availability zones. So what I'm going to do is just create a VPC here in my Oregon region, and I'm going to call it IPv6. You can name it whatever you'd like to. This is basically just a name tag that'll show up on the main screen there. And then for my IPv4 CIDR, I'll just choose something random like 10.90.00/16. And then down here is where you can choose your IPv6 CIDR block. And there's certain ways that you can bring your own IPv6 block if you own one, but you can just check off Amazon provided CIDR block and they will just allocate one to your VPC for you. And then basically they just have a network border group. It's not really selectable. It's a drop-down box, but they just have the default value of US West 2 there. And then, of course, you have your VPC tenancy, which is either default or dedicated. If you do dedicated, then you can basically dedicate a rack in the AWS data centers to your account, so you're not sharing hardware with other AWS accounts out there, but shared tenancy is just the default, and so we'll use that. Of course, you can add more resource tags down there if you want to, but for now, I'll just hit Create VPC. And as you can see right behind my head here, there is the IPv6 CIDR that was allocated to my account. So you get a /56, so that leaves you with whatever 128 minus 56 is, 72 bits for your host addresses. And then what you're basically going to do is assign I think it's a /64 to each of your subnets. So each subnet is going to have an additional 8 bits on the IPv6 CIDR block that you get allocated to you, and then that will be your subnet space that you can then allocate hosts to. So we've got our VPC here. Now we need to create some subnets. Right now I just have subnets in my default VPC. As you can see, let's actually see what our VPC ID is. So it's 0167. That's what you're going to want to look for in that VPC ID. So let's head over to subnets, and then we'll create a new subnet. And of course, we're going to choose our IPv6 VPC. And when you create a subnet in a VPC that is IPv6 enabled, you'll have the option to assign an IPv6 CIDR block. So you don't have to enable IPv6 for your subnets. If you have certain subnets that you strictly want to use IPv4 for, then that's perfectly fine. But you can optionally enable IPv6 CIDR blocks in your subnets. And then, of course, a subnet being an AZ-specific or availability zone-specific resource, you get to choose which AZ you want that created in. If you choose no preference, AWS will just assign your subnet to a random, or at least seemingly random, availability zone. And keep in mind, too, that certain AWS services will work in certain availability zones. So if you're doing like AWS directory service deployments, for example, there might be only certain availability zones that are supported. So it is something that you want to consider depending on which services you're using. But in general, if all you're doing is deploying EC2 instances, in general, there's not really that much of a difference. There can be capacity differences between the different zones here, but generally speaking, if you're just deploying like, M5 instances or C5 large instances or something like that, those are generally available in most of the availability zones. So let's go ahead and just choose, let's say 2A, and I'll call this, let's say public subnet 1. And you have a checkbox here. So if you want to do IPv6 only, you can do that and basically just say, I don't want any IPv4 addressing in this particular subnet. So if we check that, you'll see that the IPv4 box actually disappears. And then for the IPv6 configuration here, every subnet gets those additional 8 bits that I was talking about just a minute ago. And so on top of the /56 here, we can choose 2 additional characters that we want to assign as the network prefix for this particular subnet. So you could do just 0, 0, 0, 1, 0, 2, 0, 3, 0, et cetera, all the way up to FF, because these are hex values. And so what we could do is say, I don't know, let's just do 0, 0 for now. And then I'll click on Add New Subnet, and I'll put one in, let's say, US West 2B, and I'll call this Public Subnet 2. And I'll make this IPv6 only as well. And then I'll give it 01 as the network prefix. And you can't obviously use the same prefix twice. If I was to try to do that, it's not throwing any validation errors right at the moment. But if I were to hit create subnet, you can see we get this error here that says that there is an overlap, which is not a valid configuration. And so we don't want to confuse our routing table, right? So here we'll just choose 01 for this subnet. And then, of course, we could add other subnets. We could do something like an IPv4 zone here. So let's do like 10.90.1.0/24. And we could put that into A. So let's call public IPv4 public 01. And I'll say don't assign v6 to that. And then we'll say add another public subnet here, and I'll make IPv4 public 02. And I'll do 10.90.2.0/24. And we'll put that in, let's say, 2C. So I have 2A and 2C. And then for IPv6, I have 2A and 2B. Not that it really matters, but I'm just kind of taking note of that as I go through this. And then I'm going to add one more subnet here. And I'm going to make this one dual stack. So I'm going to enable IPv4 and IPv6 for this one. And let's put it in 2C. And I'm going to choose an IPv4 block of 10.90.5.0/24. And then let's call this dual stack subnet 2C. And then for IPv6, I'll do a custom IPv6, and then I'll just do FF for this one. And yeah, that looks good. So let's hit create subnet here, and that'll go through and just provision all of our subnets. And now, if I just get rid of these dumb filters, I can do a VPC level filter and say, show me only the subnets for VPC 0167. And sure enough, here are the 5 subnets that we just created. And as you can see over here, under IPv4 CIDR, 2 of them do not have any IPv4 addresses associated with them. And then right here, you can see that 2 of them are IPv4 only. And then 1 of them is dual stack. So we've assigned IPv4 addresses as well as IPv6 addresses to that. Now, it's kind of funny, they say available IPv4 addresses, but they don't have available IPv6 addresses because, I mean, it's just something they probably overlooked, but /64 is an incredibly large address space. In fact, if we fire up PowerShell here, and just do math power, let's say 2 to the 64th, yeah, that's a big number. So it's basically 1.8 plus another 18 zeros after that, roughly. And so that's a really big number. So you're never going to run out of IP addresses, truly. With IPv4, they may have said that you'll never run out of addresses, but as we all know, IPv4 is exhaustion is real. So we've got our network set up here. Now what we need to do is take a look at our route tables. And so the route table obviously is how we configure our routes to the internet and to other VPCs if we had them, or other networks. If you had like a 0-tier network set up and you wanted to connect a 0-tier network to your VPC, you could do that. I've actually got some training at CBT Nuggets that talks about how to do that, which is pretty cool. But actually, let's go ahead and create an internet gateway first. And this is just an easy step. I'll just call this IPv6 gateway. Now keep in mind that internet gateways as a resource in AWS are not protocol specific. So an internet gateway is IPv4 and IPv6 inherently. But I'm just giving it a name, just like IPv6 gateway, just to serve as an identifier. So let's hit attach to VPC, and we'll attach it to our 0167 ID. So now it's attached, and we need to set up our route tables to send traffic that is destined for the internet out through this internet gateway. So let's head over to route tables. And by default, when you create a VPC, you always get a couple of default resources. You always get a default security group, and you also get a default, or what they call a main route table. And so right over here under this main tab, you can see it says yes. It's this one right here, because they were looking at VPC 0167. So let's filter it down. And sure enough, there's our main route table. And by default, if we take a look at the routes in the main route table, you can see that we have local routing set up. So basically any traffic that's destined for our VPC supernet, the 10.90/16, that will all be internally routed within the VPC. And same thing for our /56 IPv6 prefix that was allocated to our VPC. That's all just local traffic. But we don't have any routes. So if we were to send traffic out to, 1.1.1.1 or 8.8.8.8 or google.com or anything like that, we're not going to be able to route out to the internet. So I am going to create, let's actually create a new route table. And I'm going to create one for IPv6 only. So let's give it a name, IPv6 only. And we're going to put that in our VPC 0167. And we'll hit create. And then inside of this IPv6 only route table, I'm going to hit edit routes. And in our routing table configuration here, I am going to do add route. And then we'll say anything that's destined for the internet, we want to go through the internet gateway. And I don't think, yeah, it's not going to let me remove the IPv4 rule, so that's going to have to sit there anyway. We'll hit save changes, and then once we've got that set up, we can go ahead and associate this with a couple of subnets here. So we'll do subnet associations and say edit, and then we'll associate it with the two subnets here that are IPv6 only, so they don't have an IPv4 block, and then we'll just hit save, and then we'll create another route table. Let's just call it IPv4 only. Hit create. Oh, let's choose our VPC here. Hit create. And let's do edit routes on that as well. And then we'll go ahead and set up a route for 000/0 and say go through the internet gateway. So as you can see, the internet gateway works for both IPv4 and IPv6 routing table rules. And then let's associate that with our two IPv4 only subnets. And then we'll go ahead and just leave the main route table implicitly associated with the remaining dual stack subnet here. So if we go to the dual stack subnet and take a look at route table, you can see it's still got the just main route table that just has the local routes there. So I'm going to go ahead and just use the main route table for that, but I am going to add those same routes. And I'm really just adding these route tables just to serve as kind of a demonstration of how you can assign subnets to individual route tables, or you can just fall back on the default main route table here. And that if there's no explicit association between a route table and a subnet, then the main route table is the one that's used by default for any subnets that don't have an explicit association. All right, so we'll just add a couple of rules here just for our dual stack subnet so we can route traffic out there as well. So now we have several different route tables set up for IPv6 only, IPv4 only, and then our main route table down here. And again, they're all pretty much doing the same thing. All they're doing is routing traffic out to the internet. But as I mentioned, I'm just kind of doing this to demonstrate how you could create unique sets of routing table rules and then associate those with certain subnets and not others. All right, so now our routing tables are set up to send traffic out through the internet gateway. And let's go ahead and take a look at our subnet configurations as well, because there are some default options that are not always set up on these. So for IPv4, I'm going to edit subnet settings. And I'm going to say enable an auto assign a public IPv4 address. So when we go through the EC2 launch wizard, or if you're using Fargate or something like that, then it's automatically going to assign a publicly routable IPv4 address. So let's enable that. And we'll enable that on the second IPv4 subnet as well. And then for our IPv6 subnets, so let's find public subnet 2 and 1. We'll do edit subnet settings. And of course, we've got this checked here to enable auto assign IPv6. And I think that's checked by default because it's IPv6 only. I think if we go to the dual stack one, yeah, if you're on the dual stack one, it doesn't force you to enable auto assignment of an IPv6 address. So if you do have a subnet that has both IPv4 and IPv6, you'll most likely want to just come check that box, and that'll save you an extra step whenever you're launching resources into that subnet. All right, so at this point, we've got our subnet options set. We've got our CIDR blocks. We've got our auto assign settings set up. And now I think we're pretty much good to go to the point where we could launch an EC2 instance. So let's head over to EC2 and just launch a new instance here. Sorry, the sun keeps coming in and hitting my green screen. So let me fix that. And so now what we want to do is just find an AMI here. Let's choose Ubuntu Server. That's what I typically use for Linux-related stuff. And then we'll choose, let's say, T3 small. And I'll do request spot to save a little bit on the hourly spend. And then down here, you can see if we choose our VPC, IPv6, here's our 5 different subnets in that VPC. And now what we could do is say, like, I want to do IPv6 only. I'll choose public subnet 1, which is IPv6 only. And it's kind of funny, it says 0 IP addresses available. I think that's kind of funny because there's actually a metric ton of IP addresses available. They're just not IPv4 addresses. Kind of a friendly bug in the console here. I'm not sure what would happen if we tried to auto-assign a oh, it won't let me do a drop-down on that. It should be grayed out, but it's not grayed out for some reason, but I can't click on it. That's so bizarre. All right. And then if we choose the dual stack here, the dual stack one has the options to either enable or disable public IPs for IPv4 and IPv6. And then if we choose IPv4 only subnets, then that IPv6 option just completely disappears. So it's just not applicable in that particular subnet. And as you can see, it changes to say 251 IP addresses available. They should really add something to indicate how many IPv6 addresses are available, because it's a lot. So for starters, let's deploy one in the dual stack subnet that we created, and we'll just leave both of these options enabled, so it'll get both IPv6 and IPv4. And let's go ahead and hit next, add storage. I don't really need any more storage. Now for the security group here, I'm just going to choose my default security group. And keep in mind that the default security group, when you create a VPC from scratch, doesn't have any inbound rules set on it besides just the internal allowance of all network traffic between devices. So by default, any devices on the VPC can communicate with other devices on the VPC. And I'm actually going to fix my green screen here because my hair is starting to look a little bit transparent. It's kind of funny. All right, how does that look? No. Lower? Yeah, there we go. Oh, that's making it look like crap. All right, I guess my hair is just going to have to be partially transparent. All right, so let's do review and launch, and then we'll do launch, and I'll choose my SSH key here. And we'll let those go ahead and launch, and then we'll get SSH'd into it. So let's head over to instances. And then we'll log in to our instance here. And what's nice about the EC2 console here is you can see on the details screen that we have an IPv6 address here, and we also have an IPv4 address. So we can SSH into either of those, but we need to set up a security group rule first. So let's head over to the security group for this VM, and then we'll do edit inbound rules, add rule, and of course we want SSH port 22, and then the source is going to be, let's say 000 for v4, and I'll just call this SSH IPv4, and then we'll create another rule that says from anywhere IPv6, same thing, SSH, and then we'll say SSH IPv6. All right, so we'll save those rules. So we should be able to SSH in now to either the v4 address or the v6 address. So let's head back to instances, and I'm just going to copy, let's say, the v6 address for now, and fire up my terminal. And let's do an SSH Ubuntu at, and plug in my IPv6 address here. And sure enough, it says confirm the key fingerprint. And voila, we are logged in. So as you can see, that's v6. And then of course, we could do an SSH in through IPv4 as well. Let's just verify that. I'll grab the v4 address here, plug that in. And that works as well. Sweet. All right, so we are able to access our EC2 instance through either IPv6 or IPv4. So let's terminate that one, and then let's launch another one. I'll do Ubuntu here, and we'll just do a T3 small, and do spot. And for VPC here, we'll choose v6. And then for the subnet, I'm going to choose, let's say, how about public subnet 2? That's one of the ones that's enabled for IPv6 only. I wish they would make this disappear kind of like they do in reverse, where if you choose a v4 only subnet, that it makes the v6 option disappear. Just kind of a usability thing, because it looks like I should be able to click on this, but I can't. That's the AWS Management Console. What can I say? So we'll, of course, leave IPv6 enabled and choose our default security group that has our rule right here for v6, port 22. And launch. All right, so let's check this one out now. And of course, I actually got a, oh yeah, we did IPv6 only. So I was kind of half expecting to see it allocate a public IPv4 address, but we don't want that in this case. So we've got a v6 address here, so we can just copy that. And if we refresh this a couple of times, you'll see it never does actually get a v4 address. This is in one of the subnets with IPv6 only enabled, which is very good in my opinion. All right, so let's fire up another terminal here. SSH Ubuntu at IPv6 address. And it looks like it hasn't come up yet. Oh, there it is. Sometimes they just take a couple of seconds to come up. Oh, looks like I chose the wrong SSH key. I always get that screwed up because I have a couple of SSH keys that I use for different purposes under my key pairs here. So anyways, you kind of get the idea. If you create a VPC, you want to make sure you set up your security group rule for v6 access across whatever service it is that you want to use, and IPv6 access or route tables as well. So you want to make sure you set up your route table for routing IPv6 traffic out to the internet. So I'm actually going to launch another one here, and I'm going to make sure I use the right SSH key this time. We'll do T3 small, spot, v6, use one of the v6 subnets, and choose our security group here, and launch. And all right, so that's launching now. Good. And let's get logged into it. And then what I'm going to do is just install an application on it. So something like Nginx maybe, and start that up and make sure that we can access it from across the internet. So let me just do SSH Ubuntu at IPv6 address. Looks like it's going to take a second to come up here. Come on, you can do it. Come on. Did I get the wrong one? I have a feeling I got the wrong address. Yes, I got the wrong address. All right, that's the right address. And then let's do sudo apt update and sudo apt upgrade -- yes and sudo apt install nginx. Yes. All right. And then that should get nginx installed. Now, one thing that I haven't actually taken a look at yet is how to, if it's possible to set up the Docker daemon to be IPv6 only. Because normally what I would do is not install an application on the actual host itself. What I would do is install Docker and then run containers. And I did do a little bit of research on Docker IPv6. And I think somebody said that you could enable IPv6 and then I don't remember exactly how that works, but I think you can enable IPv6 and then just have it kind of run without an IPv4 address. And it looks like we're actually going to run into an issue here where the default Ubuntu image is actually not happy. It's trying to reach out to an IPv4 address to update the apt repositories. So see how it tried to connect and it says it timed out because it doesn't have a v4 address and so it can't get out to the internet. So yeah, that's interesting. I had not previously noticed that behavior. I'm actually going to pause this really quick so I can fix the green screen. And of course I can't fix that window. I don't have any blinds on it. So we'll just have to, I guess, live with that little bit of sun as it creeps into the picture. Probably shouldn't have done the apt upgrade. I probably should have just done apt install on nginx. I really don't need to update most of these packages, probably. But let's just let it do its thing. Oh yeah, it's going to try to connect to the IPv4 repositories again here. So that's actually kind of an interesting issue. I need to do some research into how to resolve that. Because yeah, that's actually for the nginx package that it's trying to do that. So I guess we're maybe not going to be able to install nginx for the time being. But if we could, then you know, we'd be able to test out connectivity. But in any case, if we were to open up any additional ports there, we just want to make sure that we come back to that security group over here on that instance and just add an inbound rule on it so that we could access HTTP traffic. You could always just do custom TCP and say port 80 and enable IPv6 inbound from anywhere. So that's theoretically what you would do, but I think you guys kind of get the picture that this is how you can set up a VPC for IPv6 only, IPv4 only, as well as dual stack. We didn't cover anything like creating a private subnet for IPv4, but that's something that's been around for a long time. You basically just create a NAT gateway and then you set up a route table for your private subnets and you route traffic out through the through the NAT gateway instead of the internet gateway if you're looking to create a private IPv4 subnet. With IPv6, obviously things are different because IPv6 addresses are going to be inherently routable on the internet. And so you need to be thinking about things differently. You don't have that, people treat NAT-like security. And while I suppose it does kind of provide security by obscurity, the firewall is really what is doing the security for your network. And so IPv4 addresses, in theory, should be publicly routable, but we've just kind of, in practice, put everything behind NAT, which just complicates our lives. You have to set up port forwarding rules and all that fun stuff, and it's just kind of a hassle. So if you go with IPv6, you don't have to worry about doing port forwarding anymore. NAT is kind of a thing of the past that we don't need to worry about. However, you do need to take special care that your firewalls are set up properly. Anyways, I'm going to stop the video there. and I hope you guys learned something from this video and enjoy setting up IPv6 on AWS. Take care.